In the previous session, we learned about the @primary annotation for resolving the ambiguity and ambiguous situations in which more than one bean definitions were amongst the candidates for a single injection point. And we use this primary annotation to actually inform the spring that our choice when the ambiguity rises is this single bean definition. But as you saw, it has some shortcomings. It is limited, and if we want to have more control over how the spring is going to resolve the ambiguous situations, we have to use something more powerful. So in this session, we are going to learn about this qualifier annotation, which is yet another annotations and among the annotations in the spring that we could use when we use annotation-based configuration. So what it does is that, again, this is for solving and resolving the ambiguity situations. So we talked about the ambiguous situations in the previous sessions, and if you remember, it was like when you use the @AutoWired or @inject in some injection point, like your parameter or field, and when there were more than one, because the @AutoWired works resolves by type, when there are more than a single, let me get rid of these primaries. When there are more than a single one that its type could satisfy, because this one is also extending this engine. Now, those two could satisfy this type, and because of that, the ambiguity situation rises here. So, if there are any primary, it will first select the primary one. But if amongst the candidates, amongst the resolved candidates, if there are no primary, there are no bean definition that is annotated as primary, it will try first to use the name of the injection point to compare with the bean definition names amongst the candidates. So if you remember the previous sessions, we were actually expecting the AutoWire to fail, but somehow it was working, and then we changed the name. It was because that when the ambiguity rises, it looks for this name here. So when the injection point is a field, it looks at the field name. When the injection point is constructor parameter or setter parameter, it looks at those parameter names. So what it does is that it takes this name and it compares with these two or more than two candidates, and with their bean definition names, of course. The first one has the name of engine, and the second one is super engine. And because the names are unique, as you know, the bean definition names must be unique, then if one of them matches this name, the injection point name, then it will be able to resolve the ambiguity. So if we run it, you will see that it fails. But if we change it to, for example, super engine, okay, now among one of those two, this one is named engine, this one is named super engine. As you see, the super engine class has been instantiated and the bean definition has been resolved. So that is the first way of doing that, but it has some shortcomings, because first off, it is actually, again, yet another ambiguity, because when you deliberately choose the name of the field just to help the spring to resolve the situation, then at some later point, you might actually try to change it and it will fail. So that is a bad idea. And so that is the first thing that we could use. Now, if we don't want to use that, we could use the qualifier annotation. So the way that the qualifier annotation works is that you could annotate either the injection point or the bean definitions or both of them with the qualifier annotation. So if you annotate these with add qualifier and giving some name, for example, simple engine, simple, and this one you are annotating with, again, qualifier, and naming it super. So you are adding more detail here. Now, actually, we have added annotations to the bean definitions, not the injection point yet. In this case, when the injection point or the destination, when it is not annotated with add qualifier, then again, when the ambiguity rises, it will, for that injection point, it will first resolve, it will first, amongst the candidates which has been resolved by their type, it will ignore all the qualifiers, because the injection point and the destination does not have the qualifier annotation. So when the injection point doesn't have the add qualifier annotation, it will ignore all the qualifiers of the candidates. So again, it will fall back. Now, if I change this name, for example, to something else, some silly name, again, it will fail. But if we change it to, for example, the name of one of those so you can see that it is choosing engine. Now, if I, for example, select this, change the name to, let's name this, for example, super, for example, because the super cannot be. Let's use this word here and see if it will choose this one over this one, because the name, if it will actually choose this one because its name matches its qualifier, not its component, not its bean definition name. But you will see that it will fail again because the injection point is not annotated with add qualifier. When it is not annotated with add qualifier, it will ignore all the qualifiers. So when it ignores this one, it means that it does not exist at all. It's like it does not exist. So when it does not exist, it will again look for the bean definition names. So that is the one situation when only the bean definitions are annotated with add qualifier and the injection point is not annotated. Now, what happens if the injection point is annotated with add qualifier as well? For example, with some name ABC or super or something. Now, in this point, when the injection point is annotated with add qualifier, it will actually first it will, the add autowire, as you know, will create a list of candidates by choosing the ones that their type satisfy the injection points type. Now, inside that list, because the injection point is expecting a qualifier, inside that list, that resolved list, which might have more than one candidate, it actually again tries to filter that list. So when it filters that list, it takes the qualifiers of the bean definitions, takes them into account. So when, for example, you say ABC, I want the one that has the qualifier of ABC, it goes and it looks for the qualifiers among the candidates and selects those that has the same qualifier, for example, this one, and for example, this one. And the one thing that I should mention here is that the qualifier does not have to be unique. They are not unique like bean definition names. So as you can see, both of them has the same qualifier. Now, so it won't help here again, because again, we resolved by type to a list of two candidates, and amongst those, both of them had the same qualifier as the injection point. Now, the important thing that I should mention here is that So if I first, let me show you that if I change the name to something like soup ABC, and let's name it ABCD. Okay, it changed this. It selected the super engine because the super engine had the same qualifier. So another important issue that I should mention here is that as a fallback mechanism, the Spring takes the name of the bean definition as a qualifier as well. So when we, for example, say ABC, not only it selects and filters those ones that has the same qualifier as ABC, but it will also select the single one that will have the same bean definition name. So if, for example, this one, let me override it and name it ABC, okay? EFG, for example. So now this bean definition will have the name of ABC, and this one will have the qualifier of ABC. So both of them again will be the candidate, and again it will fail because the bean name also counts as a qualifier, you know, and it will be used. So again, in this situation, when actually two or more than two amongst the candidates, when more than one candidate again is filtered, again we have a list that we have more than one candidate, and we cannot select the one and resolve the ambiguity. So what it does, it fallbacks at this point. It fallbacks to the name of this injection point, and it sees if it could resolve it this name. So because this is ABC and this one is ABC, and if we change it to, for example, ABC, or let's change it to super engine. Let's change it to super engine, and it will compare this with the bean definition name, not with the qualifier, of course. So the one with the bean definition name, same as super engine, will actually win here, and it will be injected. So yeah, you could see that maybe some time using it seem a little bit confusing. It needs actually more practicing, and also you should avoid situations that are ambiguous. You know, the qualifier name should be structured. For example, you should have naming conventions like A dot, B dot, for example, packaging convention, to make it unique and help. And also don't actually rely on the name of the injection point, because that is so harmful. So those are the things. And when it resolves, as we said, when it filters the list, the primary list, which has more than one candidate, at last, when it has only single bean definition inside it, it will choose that one, and it will create instance off of that. Okay, another interesting thing, and the last thing that I want to mention here, is that we could, as you know, we had a complete session, an episode about meta annotations, that it was about that we could create new annotations of our own by composing and annotating our annotations with the Spring built-in annotations. We could actually use that pattern here to make the application more readable and define better and more qualifiers, you know, because these qualifiers are string literals. So like we said, if you've not seen that session, just go back and watch the episode about meta annotations. So I'm going here to create a new annotation, and for example, name it, for example, fuel, for example. And the idea here is that I'm going to annotate my engines with fuel annotation as a qualifier to help to resolve the ambiguity situations, to help the Spring to select between one of them based on the qualifier on top of the injection point. So let's say that we have this fuel, And let's create an enum here and name it fuel type. Okay, for example, gasoline and electricity. So now we could define this type outside of this interface, but I prefer it this way. So now let's define two attributes. The first one is the fuel type, and the second one, let's say for example, capacity, the capacity of the fuel, or I don't know, maybe the capacity is not a good attribute for the engine, but let's just leave it as is. The domain doesn't matter here. So we have this annotation. We have to annotate it with target, of course, and say that it could be annotated on top of the parameters, because we want to be able to annotate the constructor parameters and setter method parameters, the injection points. Also, we want to be able to annotate the fields and also the components, which are classes. So the type should be amongst the targets as well. And also the retention, we make it as runtime. Now we go ahead and annotate it with add qualifier. So when we annotate it with add qualifier, this is a meta annotation, and we are creating a new composed annotation. And we could now use the fuel here instead of this qualifier and tell that, okay, I want the fuel type. So the fuel type of this engine is gasoline, and its capacity is 10, for example, whatever. And let's also change this one to fuel again. The super engine will be having the fuel type of electricity, and its capacity is 20. Okay, now we have custom qualifiers in the bean definition points. Now we have a qualifier in the, so all the rules of that we talked about, all of them holds the same here. You know, nothing changes. The only thing that changes, and we could say that it doesn't change, is that this qualifier in the injection point should match, exactly match, the qualifier on top of the bean definition point. So this will obviously won't match. So if we want to match, we should have, for example, let me change this one to A. We should have, for example, let's say the fuel type as gasoline and the capacity as 10. Now, it is obvious that this one and all its attributes should match. You know, it is important. All the attributes should match the destination. It matches this one, and it will choose the engine for us. Now, if I change it to, for example, 12, because amongst these two candidates, amongst the candidates that were resolved by type, there are no qualifier, you know, that matches this fuel with its attributes, all attributes. It just fails. So let's change it to electricity and 20. I think it was 20, to prove that it will inject the super engine. Okay, so as you can see, we use the meta annotations to create custom qualifiers, and it is a great feature, you know, because you don't have to actually have these attributes. It could be without any attribute, and then if you don't select any attribute, it will choose the one that has the same fuel, has the same attribute, sorry, has the same annotation. So and as I said before, all the rules that we just mentioned, all of them holds here as the same. And the interesting thing here is that we could not have more than one qualifier here with the add qualifier, because we could not have repeatable qualifiers, but we could have more than one custom qualifiers, you know, and that is another benefit. So I think we are done here, and we just explained how to use qualifier and custom qualifiers to help the Spring IOC container to resolve the ambiguity and change and select amongst the candidates in the ambiguity situation.